Hello everyone, welcome to our last workshop, our last Arduino workshop. So today we're kind of going to tie some things together and write some code where we can control the speeds of the motors from our computer. And I don't think we're going to have time to go as deep as we could with this, but this could be the groundwork for a processor controlling the motors for like a tiny cart, where your NUC would be determining the speeds that it wants the motors to spin, sends that over serial. The motors, or the Arduino, reads that value in serial, converts whatever format the NUC sends to a usable format that the motors can spin at, and then commands them to spin. So what we already did was we looked at the L293D motor driver chip. So this has two H bridges built in. And we worked with H bridges before, but this is a lot simpler because it's all condensed into one chip. And we looked at the pinout and we figured out how to work with it. So now we're going to move on to the code. One quick thing. So one thing that was a little bit different than how you have to wire up this H bridge chip is normally these two enable pins, you can just connect them to 5 volts and then your motors are always enabled. Right now we're using 6 digital I/O on the Arduino to control 2 motors. And you can just connect the 2 enables to 5 volts and then you only have to use 4 I/O pins. But the reason I did that is so if you use just 4 I/O pins but you want to specifically change the speeds of the motors, all 4 of those pins have to be PWM enabled pins. If you do it this way, only the 2 enable pins have to be PWM enabled. So you can think of it as the input 2 and 7 will change the direction, will set the direction that the motor wants to spin, but then actually turning on pin 1 is what makes that motor spin. So if you're turning pin 1 on and off very rapidly, like what we do with PWM, and you can change that rate, you can change the rate that the motor spins at. So I did this just to kind of show another way that we can set up an H bridge, and it also worked a little bit better for me because some of my PWM pins were acting funny. So does that make sense? Okay. All right, so then if you guys want, I emailed you all the timer code. It's the code we did for the 5th workshop, where we talked about interrupts, and then we also talked about timer interrupts. But I figured I'd just email it to you guys. We're going to use that as a blueprint to build what we want to do today. So if you guys have that pulled up. Pull this here. Let me save this. All right, so if you remember, what we did this time is this was just a proof of concept showing how timer interrupts worked. So we had like an LED flashing, and that took up all of the main loop. But then every millisecond, this timer would trigger, and it would interrupt the main program, and we'd check to see if any serial inputs had come over across our serial line. So we're going to use that basic format for this example because it's very similar. The user is going to type in a speed and send it, and we want to constantly be checking to see, did we get a serial message? Did we get a serial message? Okay, we got a serial message. We got to parse through that, determine what values it is, and send it to the motors. Now, so what we're going to do, so we already have timer 1, we already have the LED. We are going to change these strings to arrays, to character arrays. So have you guys worked with arrays at all? I'm sure you have. You guys maybe not. Okay. So with a string's very easy to use, but sometimes it can have some pitfalls. And in this example, it's better to use an array. So what I decided, here, I'll type this at the very beginning. we are going to define this. So in this code, we're going to have an input, which is going to be the speed commands over serial, and this is the format that they're going to come in. And this I just kind of made up myself. You would have to make sure that this format agrees with whatever format your NUC is sending or your computer. But we got an L and an R and then a number. And I did 00.00, and then if you wanted to send a negative speed, it would be negative sign 0.00. But what we're basically doing is we're going to define that this is what your input's going to look like every single time. And so we also know for sure that it's going to be the set length of, I think, 16 characters. So how an array works is, you remember what a char is? It's just a data type that can store a letter or a number. If we have this char array, so to show that it's array, we do these brackets and we put a number inside, which basically in this example means we're going to have 4 characters all grouped into this one variable named name, which I shouldn't have done that, but I'm just showing name is going to equal my name, J-O-E, and then this weird character, which we'll talk about in a second. And each of these is its own individual char, but then they're all grouped together in this array. So if you wanted to reference the first character, you would do this name, and then brackets, and then 0, because this is the 0 position, the 1 position, the 2 position, the 3 position. If that makes sense. We also have, this is the null character, which just shows that we've reached the end of our array. We don't necessarily have to have this, but if we want to print this, we do want to have this. It makes life easier. And using arrays can sometimes make life easier. Say I want to suddenly set this all to 0. Well, maybe not make life easier, but some neat tricks you can do with arrays is they work very well with for loops. So if you know that your array is a length of 4, you do a for loop where you start with 0, you work your way up to 4, and then every loop you're going to interact with the next character. So the first loop, I is going to be 0. We're going to interact with the first character. The next time, I is going to be 1. So name 1, that's the second position, the first position, which is the second character, and we can interact with it. In this example, we're setting it all equal to this null character, which just means we're kind of setting it to a blank name. And then maybe in the next one, we'll do the same for loop and set it equal to someone else's name.
I wouldn't set them all to null. That's going to mess with things.
What?
Yeah, I wouldn't set them all to null. Are you going to mention later how strings work in relation to this?
I mean, I wasn't going to. You can mention it.
Here, I was I'll just show it here. Just I'm just going to introduce real quick because this is just useful C++ programming particularly. So this whole thing here, like char name for and this all, there's another syntax for this. You've already seen it. It's just like a string. It's like if you do J-O-E, or just Joe. Yeah. Like that. This string is literally the exact same thing as this. The difference is that you don't have to do the manual null terminator here. That's what this is called, that little /0. Because how strings are handled under the hood in C and C++, but this is mostly a C thing, is that this like /0, this null char, is used to find where the end of the string is, because when you pass an array to something, you don't actually say how long it is, so they just kind of have to guess. What a lot of these standard library stuff, like you probably won't use these, but there are functions that are like, oh, replace this letter with this letter and such like that. Those iterate over that string, and instead of having like a defined for, it'll just say loop until you hit that null char. Mm-hmm. And so that's how it knows where the end of the string is. But this is why I wouldn't do this, because if you do use those, this is going to make it freak out, because it's going to think that the end of the string is the first character. So generally, you should only have that null char at the end of the string. And if you work with using the string syntax instead of this, then that'll be handled for you, and it's just probably
So
better.
what if you want to have a blank char array?
I mean, I would literally just use like that. If you have single quotation space, single quotation, that'll have the space character. It's like ASCII 20, I think.
Okay.
That's what I would do.
Okay.
If you have a single char, you can make it null. That's what I normally do, but I've learned that messing with strings leads to everything blowing up, so that's
Okay.
probably a good idea. And I should mention, if you do this, char name for will work with this, or you can use pointers or whatever you want. Maybe that will work.
Okay.
So basically, the string automatically like has that null at the end,
The null's
and
null,
then
yeah.
the program just finds it.
Yeah, during compilation, either of those, I mean, I said don't make them this, but both of those are called syntaxes because they both under the hood do the same thing. It's just the way you write them in code is different, but it's just two different ways of writing the exact same thing. Once the code is compiled, under the hood, the physical binary will have the exact same code regardless of how you do it. It's just a bit easier on your half.
So what we're gonna do to convert this, we're gonna have a similar format. We're gonna, I don't know if you remember from this example, but we had one variable that was the message that was currently being received. Once that was finished, we set that equal to message completely received, and then after we proofread that it worked, we put it into message to print. We're gonna do a similar thing, but we're gonna call them different things, and we're gonna make them character arrays. So we do char speed. This is gonna be interesting. To spin. We're setting this to 16. Char speed. Message. Okay. And so these three character arrays are going to replace these three strings. So I'm going to delete this. And you'll notice that count this out. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So there'll be 15 characters, but we did a char array of 16 because we want to have a spot for the null character at the end. We also have this integer speed message being received index. That will be similar. Well, we'll get to that in a minute, but that allows us to reference a specific character in this array. We're going to leave this flag message received. And we are going to have a char single character, but we're going to set that to the null character just to start. Now, to keep track, we're going to be getting a message, and it's going to have either a 0 or a negative sign. We could probably do positive or negative, but maybe I'll change it to that. But we need to have a flag that shows either if we're going forward or reverse. So I did bool left reverse. Set that equal to false to begin with. So we'll have two motors. I'm going to call the left one left, the right one right. And then I'm going to define a couple other variables that are going to change throughout the code. Oh Lord, do you not have your computer? Oh, I'm sorry. That the rest of it will be a little more boring for you. But can still follow along and ask any questions.
So where are we setting single character the char equal to null?
So we're going to use this single character later, but right now we want to set it to a good default variable, and that's just going to be the null character. We could set this equal to AB8, but then that might give us bad results later if we happen to read what this character is before we set it. So I want to set it to something safe to begin with.
I would do the same with those floats.
Yeah, I guess we could set them equal to 0.
Because if you don't do that and you read them, it'll crash the program.
Good programming practices. Still haven't learned those. But.
Many programmers haven't either, don't worry.
Actually, I changed my mind. I'm going to say loaders. This is the format I'm using for the variables. We do this snake case where we use underscores, and then for functions we do this camel case. Whenever it's a new word, it's a capital letter. Does that all make sense so far? Right now, yeah, these are just placeholders for variables that we're going to use later. Okay, here we're also going to set a few more variables because we got a lot. And then another thing that I normally do is for these constants. So these are parameters that aren't going to change. They're constants that you set once, and nothing in the code is going to adjust that. So I do these all capital, just so if you see that in the code, you know, hey, that's a parameter. That's not a variable that's changing based on what's happening in the code. That's always the same. 4, 7, 5. Now, if I had brought up some of the wheels that normally get attached to these motors, we can measure the radius. I did that ahead of time, and right now that's in meters. You guys know what floats are, right? I don't know if I necessarily explained them, but integers are numbers, but you can't have decimal points. Floats, you can have a decimal point. So for this wheel radius in meters, it obviously has to be a float. This doesn't have to be a float, but I'm setting it equal to a float because later we're going to do some math with just floats. So that makes it easier. Just make sure there's not an error. Okay. So now we have a math question. So we got the wheel radius, and we want to know how far the wheel is going to travel if it rotates one complete rotation. This is pretty basic math. But
Circumference.
yeah, so we have to figure out the circumference. So what's the formula for circumference?
Check.
Tau.
Ah, sorry.
Don't check.
It's 2 pi r squared. R, maybe 2 pi r. Something like that.
Yep. And we're going to define pi as 1415. We're going to call that good enough. So yeah, so with our wheels that we don't have right now, but if they're rotated once, that's as many meters as it would go forward. Now we could do this math and then put a number here instead of having this math, but it's better to do this because what if later we're working on a different project and we have a different wheel radius, then we don't have to remember to go back in and change that number. All we have to do is remember to change this parameter right here. We don't have to do new math.
And I should also add that's just a good idea in general if you're using constants because it's a constant, all of that like multiplication work is being done by the compiler. So at runtime, that's the exact same in code as if you wrote down a specific number. So that comes with absolutely zero disadvantages.
Yeah. Good point.
On line 30, is there a underscore between radius and m?
Yeah. I just did that for me to help remember that this is in meters. Once again, you can name these variables whatever you want, but
From what I can find in my look around code, that's actually the convention. It's just to put like the unit at the end, so that's good.
okay.
Remember in
Oh.
GPS the radius of the
So yeah, if any of these names seem confusing to you, we can name them whatever you want, but
Oh, watch out, Joe. On line 34, you got 2 L's on the left.
good catch. Thank you. That's actually how I wanted to type it.
Oh, you just, okay.
So you may recognize these numbers. These are the pins the Arduino pins that we wired up for the motors. And I guess it would, to be better than PWM, we could call these motor write enable. That might make a little bit more sense, but basically through testing we'll be able to see if we turn pin 9 on, will the motor spin forward or backwards? And then if it spins the opposite of forward, we can either swap the wires or we can go back in the code and swap forward and backwards, swap 9 and 10 right here. And I'm setting these as constant ints because this is what is plugged into the Arduino, so obviously that's not going to change while the code's running. It's not a variable that we're going to mess with. So is everybody caught up to here? Oh, wait a second.
How'd you get your zeros to have a dot in the middle?
What?
Your zeros have a dot in the middle? How'd you have to do that?
I don't know. I don't know. Does yours not?
No, yeah.
I was just curious if you did. I don't know.
Oh, because probably your Linux has that.
Maybe. Maybe. All right.
Hey, Joe.
Yeah.
How do cars measure like the distance they travel, like total mileage?
How do they measure? Like, how? Like, what sensor do they use to measure that?
Yeah, or do they just yeah.
Well, encoders would be one sensor.
Okay.
So if you're counting the ticks, and this has like 20 holes in it, and you count 20 ticks, then you know that your motor has spun one complete revolution. And then doing some of this math, where you know the circumference of your wheel, you can estimate how far forward you traveled. Obviously, like autonomous cars will need more accurate sensors because this isn't super accurate. And like ohm needs more accurate sensors. It's similar. So that's where it starts getting into like slam, where you saw an obstacle that was 5 feet in front of you, now it's 4 feet in front of you. Unless it's moving, that probably means that you've moved a foot forward. And then there's other techniques like that too.
Okay.
There's sensors that can detect like acceleration and IMU. So Andy, so what I was going to do is at the very beginning set this character array to all nulls,
Correct.
just because I want it to be a blank array right now.
Correct.
Would that not be good practice? Would it be better to set it to all spaces?
I mean, if you're doing it entirely yourself, for this it doesn't matter. What I would
Okay.
normally do though, because I like to use the C standard. At least even in C, there is a standard library of like various string manipulation functions, and all of those rely on only having an null terminator at the end. So for what you're doing here, this is technically fine. Generally, what I would do though is put it all to all blanks probably.
Okay.
And then have the null at the end, and then all my for loops, I wouldn't have like going to 16, I'd have going till the character is null.
Yeah.
And that way you don't need to hard code the length of your array for literally everything. And instead just go until it hits that null char. But again, if you never hand the string over to anyone else, then this is fine. It's just that's the C convention, and
Okay.
any code you send your string to that's written by someone else will assume that it has only one null char at the end. So it's just generally
So if I have a character array of 16 and maybe I have 14 filled up and I have 2 nulls at the end, that could cause a problem.
yeah, you would only want it would just treat that string as if that second null didn't exist and was outside of the array and out of bounds.
Okay.
So
Because that would be fine.
Yeah, I mean again, you can do that. It's just code
Okay.
will get kind of weird. Because if let's say it tries to insert another character, it will think you're basically just using up storage you're never going to access, because the code would assume that's out of bounds and will never access it. So it will never replace that null char with another character.
Okay.
So it's just convention of how.
So if I had 14 characters, I should then have like a space and then have the null character at
Yeah,
the end.
usually I use blank
Okay.
as a thing. Again, it's just weird conventions from the 1970s, but
Yeah.
that's just kind
No,
of
that
C.
makes sense.
C++ doesn't do it this way, just C. But
I'm trying to decide if I want to change that or not.
I mean, it's up to you.
I think I'm just not going to change that for this exam.
You could basically, because you're working with serial, you're in a bit of a unique scenario. You could basically have those be outright bytes, and it would still be useful. So normally this is more relevant to like, it's a web server and you're receiving like, a client's data.
Yeah.
This is a little bare metal, so like honestly, it probably doesn't matter as much. But that's just
Okay.
the conventions.
Okay. Well, that's good to know. All right. So yeah, as you just heard, maybe this isn't necessarily the best way to implement it, but we're going to implement it this way right now. I'll make sure this is a null character. Basically, what I want to do is I want to set all my character arrays. I want to make sure they're empty. I want to make sure there's nothing in there. So I'm going to set all of them, all the characters to null. Now I could go in and say, okay, speed to spin 1, or speed to spin 0 be null, speed to spin 1 be null, and type every single line. But with a for loop, this speeds up the process greatly. I just have to write one for loop, write them down once, and then it'll iterate 16 times and fill in all 16 characters the way I want it. I'm going to do this now. If I forget to implement this later, please let me know. But I'm going to do up here int char array length and set that equal to 16. So then, instead of hard coding in 16 everywhere, I'm going to set this equal to 16, or this variable, which I guess could be a constant parameter. Yeah, you know what? We're going to go and make this a constant int, because it's not going to change throughout the program. That makes sense? The motivation behind that. Just so I don't have to type in a 16 everywhere and then I accidentally type in a 15 and then the code doesn't work. Alright, some typical Arduino stuff. We're going to make sure that the LED is set to an output. We need to set, I would just copy this, and I need to make all of the motor pins outputs. Left. And this is going to be motor left, backward. Motor left, PWM. Motor right, forward. So this just sets all of the motor pins the way we want, all the outputs. We then can serial begin, because we'll be using the serial. Set a quick delay afterwards, just like we did before. We will initialize the timer, timer 1. And remember, this is in microseconds, so 1,000 microseconds is 1 millisecond. So every millisecond this timer is going to trigger, and then we are going to attach an interrupt of read serial message. We can just leave that the same. Okay, we're going to set a quick delay here. And then, just to be safe, in the setup, I'm going to set all of the motor pins to 0, to ground, to low. Just so the Arduino doesn't start up and the motors are spinning. That would be a little bit dangerous.
Yeah, extract something and I decided to do something. Oh, wait, I was here when the book was written by Frank. Yeah, no, I used to follow this real more closely, but I haven't had a friend I could see something why would I I got mine for $30. I don't know why they actually had a sale for $20 for $30. That's really nice. It was a decent board at the time. Because 350 was just a mid-tier board. That's back when A120 kept over there. A120. The $30 motherboard. My high school has a box of like 50 of them. You can run 5,000 series on it.
People were joking because 850 boards couldn't it's so funny. This video of people like looking at 100x on these little boards and seeing how fast they're going up. It's hilarious.
Alright, you guys ready?
Yeah, this makes this video.
Okay. We're gonna move to the loop. So, you guys remember from the old code, inside our interrupt, the read serial message that's triggering every millisecond. If we have a full character, we trigger this flag. And so in our for loop, the first thing we do is see if the flag's triggered. If it is, we set it back equal to 0, and then we do some stuff. So we can keep, we can keep all that, but we're working with characters, so we're going to get rid of this. We're going to do another for loop. 0, I, plus then, what did I call it? Char. I think that's what I called it. So we have this for loop. So once again, we're utilizing a for loop to quickly go through a character array. I mean, this could be done with any kind of array. And we're basically setting one of this speed to spin, or setting speed to spin to whatever speed message completely received is. We don't need this. So we're going to read in, if the flag's been set, that means that we've completely received a message. We're now going to set that equal. We're going to set speed to spin equal to that message. We're going to stop the timer. We're going to change the motor speeds, and then we're going to print back to the terminal. You wouldn't need to do this like on the car, but this just gives us some feedback to make sure that it's working correctly. You could also change this to being print to like an LCD on the car, so then you can visually inspect it that it's working well. Maybe if you're using a Nook that doesn't have a built-in screen. And then we're going to do this still. Once again, this is just wasting processing power that we wouldn't want to do on the actual car, but this allows us to demonstrate that we're using interrupts correctly. So do we have that all built? Alright, well, let's work on void change motor speeds. So we're gonna 1, 2, 3, 4, 5. One more. So here we're going to define 2 more character arrays. We're going to set them all equal to all null characters just to be safe. And this is going to be the left and right speed. Now why are we setting it equal to 6? Because in our format it can be up to 5, 2 decimals in front, the decimal point, 2 decimals in back. But then that would be 5 characters, but then we do 6 because we want the last place to always store the null character. Like that. We're going to do another for loop. We're going to use a lot of for loops here. Plus. Alright, so I have a question for you guys. So we haven't quite got to this point yet, but at this point we are assuming that the speed to spin is basically going to be holding this message in this format. So we want to pluck out this part. We don't need all of this, we just need the designator for the left speed, which is this. So this is 6 characters long, but we're just going to want to pluck out 1, 2, 3. Wait a minute. No, this is right. So we only want to pluck out 5 characters because we want the 5 valid ones. So this is going to be 1, 2, 3, 4, 5 in this left speed char. But which characters are they going to be in this char that would be holding this?
0 through 4.
So 0 starts here, so it would be 0, 1, 2, 3, 4.
So 0 to 5.
Well, we don't want to include this L.
Oh, we don't.
No, because this is just a designator for us. But now
okay.
we're basically getting just the character array that's just the number, and then we're going to convert that into an actual number, like a float.
Okay.
So how can we pluck out just this part?
2 through 6.
Yeah, we could. So we need 2 through 6. Yeah. 6. So right now we have this for loop that it's this I character is going to go 0 through 5. Well, it'll go 0 through 4. 0, 1, 2, 3, 4. So how can we, when this is 0, how can we make this be 2?
I plus 2.
Yes. 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 And then when we're on the second, we're on this one, which is in place 1, we'll want to be at place 3. 1 plus 2 is equal to 3. So this will work for all of these characters. And we can do the same thing. What if we just do the same thing right in here? But instead of 2, this one will be 10. Because we'll want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll want to skip over the first 10 characters to get to the 11th one. And so you'll notice that in my variable naming, this is a good practice, I define this as left speed char because later we're going to convert it into a float. So I want to keep left speed float and left speed char separate. And here's where we actually do the conversion. Now thankfully in C, we can just use this A to F function, which will convert to a float. So then we just put in our character array here, and it'll convert to a number here. So we're getting closer. We now have a workable number we can use. We just want to do some quick checks just so we don't have an invalid number. Left speed float. Actually, oh no, wait, no, this isn't that. Here we want to see if we sent a negative number. So we can send negative speeds, which will mean the motors will go in reverse. If we do that, then this left speed float will be a negative number. It'll be less than 0. So we want to recognize that. But to make our life simpler, we're going to keep the speed as it's always going to be positive. Just it'll make it easier for our conversions later. So what we're going to do is if it is negative, we're going to convert it to positive just by multiplying by -1. Left speed float. No, I don't think that's Andy, is this right? If I want to just let this variable equal to itself times -1?
Yeah, that's fine.
Okay. I always forget. Mess up that syntax. So what this is just saying is left speed float is equal to left speed float times -1. And this is a shorthand way to write that. Oh, and then we need, remember that bool that we made? Left, reverse, true. This is a variable that we set at the very beginning. We are now going to use it. We're going to set that equal to true.
Is that left speed float asterisk equal -1?
Yes, the little star. That's true. And we are going to copy this all for the right motor or right speed float as well.
Yeah, I mean, you're double PC.
Oh, does that all make sense so far? Anything you do better?
No, I'm still not there yet. Like that level.
Okay.
It's sick. This feels amazing to hold. It's actually not that bad. For $200, you can get like a boutique mechanical like 60% for that.
Oh.
What is like this? 26?
Alright, you caught up? Okay. So now, what we're going to do is, I'm assuming that the speed that you're going to send to the motors are in meters per second. That's kind of typical in ROS, and that's also typical just at a very high level. If you want to know how fast your robot should go, it's meters per second. How many meters does it go in 1 second? and you don't have to worry about the wheel sizes or anything. But now we are at that low level where we'll need to convert that meters per second to revolutions per minute. So this is where it's kind of just some basic unit conversion math. So if you're trying to go from meters per second to revolutions per minute, we take meters over second, meters per second. We need to convert that to minutes. So we know that 60 seconds are in 1 minute. We also need to know how many revolutions per meter. And as you remember, up here, we did this distance traveled per rotation, which is meters per rotation. So we do the inverse of that, it's rotations per meter. So we do rotations per meter times 60 times meters per second. We'll get rotations per minute, revolutions per minute, because seconds will cancel out and these meters will cancel out, so we have revolutions over minutes. So that's the math that we're going to do down here. Times 60 divided by... Does that make sense? Here, we're going to do this all for one motor. Now, this is kind of an imprecise way to do it, but I think this is the best way that I could think of to do it, is because now we know how many revolutions per minute we need to spin these motors at. And if we had complex motor controllers, we could precisely tune that in. Or if we had encoder feedback, we could tune that in. We don't have time to get the encoders working, and we don't have a complex motor controller. So what I'm going to do is just roughly estimate what percent of the max speed that our desired speed is. So we know our motor max RPM is 190, which is also a rough estimate, but that's what the data sheet says for these motors. So we would know it's 190 and we want to go 150, then we can kind of calculate what percentage that is, and then we can calculate what percentage from 0 to 100% that we spin this motor, because we can do that with the setup that we have. Oh, okay. Why did I do? Oh, okay. I remember why I did this. Just for ease when we print it out later. So now, what would be a good way to air check if, like, I'll say it. So we're getting a percentage. So we're expecting this to be between 0 and 100. If we did something wrong, or if we sent in, maybe we'd sent in a meters per second that's really fast, and it's like 200% times, or 200% of what the maximum speed of these motors are, we want to recognize that and not try to like break these motors. Mm-hmm. So that's why I'm setting this actual percent speed right, which is what we're just going to apply some air checking to. Oh wait, why did I switch? Let's set these to left right now. Left. this is greater than 100, that's bad. And here, I'm not using the brackets with these if statements, which just means that only the next line is included in the if statement. And the reason I'm saying if it's less than 20% is because if you try to spin these motors too slow, they just won't spin. So if it's like 15%, I don't want to strain the motors. I'm just going to set it equal to 0. And then what I'm going to do is copy this whole block of code. And then I need to change all the lefts to rights. I know this is going on a little long, but hopefully this helps like show some formats for storing your variables and like some basic good coding practices of like having these error checks so that later when you give your motors a speed that's 300% of their max speed, it doesn't break anything. And there's definitely more error checking that we could do that we're not. All right. Does everyone have all that?
I just realized how funny this is. I just realized that we're using this to but I've been staring at this for 3 days and I'm going to do that. Okay.
Is it good?
Yeah.
Alright. So now do you guys remember that we using the map function before? It's really handy in Arduino. So when we're doing a PWM output, the number can fluctuate between 0 and 255. Right now we have a percentage which is in between 0 and 100. So we're just going to map that from 0 to 100 to 0 to 255. I'll just do the same thing for right. Now here, I'm just going to put in let's just put in some things to print back to verify that we have the correct value. Mm-hmm.
On line 142, you got percent speed less instead of percent speed right.
Ah, good catch. Thank you.
So I'm putting that in the magical incantations. Because you install both source and source at the same time. So just go with the install source. It's actually
You
better.
can do that?
Do what?
The semicolon and then right again.
Mm-hmm. And I like doing that. So yeah, I'm just gonna look at this. I like doing that with these serial prints where they're both being printed on the same line. So I can visually see, okay, I'm printing the label and then I'm printing the value. Printing the label, printing the value. You could technically write all your C code on one line. I would pity you if you tried. In line 1, there's an error. Oh.
That one time I had a friend who did that one time. And you're good. So that way if anyone asks me for code, I'll be like, you know,
That's
we want
okay.
it.
Um,
I'm not confident that was code.
It's actually exceeding the amount that they should have used to
Yeah, maybe they're more people
would
look
be
at.
ridiculous. Let alone
So why did you start off with the serial statements with the serial print on them?
Right here?
Yeah.
That's just for readability. So this is going to be a big block of 4 lines, and then I want a space before I print another block of 4 lines. It's just for readability. Alright, we're almost there.
That's a very good point. We were much more anal with I work with a texter.
Alright, so this hopefully makes sense. We're mapping our percentage to an actual usable PWM value. Then we're just doing some error checking to print. Now we did all that work just to get the value that we're going to send to the motors.
So you have to show
Okay.
it's exporting local share.
So here is where we use the advantage of having 3 pins to control 1 motor. So we can set the direction and then separately set the speed. We're also utilizing the fact that we stored a flag, whether it's in forward or reverse, and then our actual speed is a constant. It'll always be positive. No, this is low. So we can always analog write to the PWM pin the PWM speed of the left motor, but then if we're reverse, we set backwards to high. If we're going forward, we set forward to high. And then, like most of the stuff that we've been doing, we gotta do it all for the right motor.
of the problems have that issue with me, like review and just stop reviewing commits or like, well, yes, I want to I don't know what for you. I just want to merge all of them. The same with mine. It's like a review. I never accept it. So I do that. That's what I wrote a test for you. What else do you want? I changed like 5 things of code. Actually, no. It's like plus 144. It's okay. That's not that much.
Sorry. When is library post?
In mine.
You guys all here?
You good at it?
Yeah.
Okay. You got the left and the right? We actually changed the pins?
Oh,
Okay.
for the last if else, for the analog right, shouldn't you put the PWM right?
Yes.
Nice catch, Evan.
Thanks, Alan.
And then what we're gonna do for time is if you go back up, we declared this print to terminal function, a separate function. We're just gonna delete that. We're not gonna do that right now. It's the same thing right here, print to terminal. I'll just delete that.
Where is this one?
Oh, so at the very top where we declared all the variables and there's the void change motor speeds, that's one of them. The other one was in your void loop in between timer 1 stop and timer 1 restart. Got both of those out? Alright. So then the last thing we just have to do is this void serial message receive, which is basically all code that we've done before. We just have to make sure that it's up to date with our new, the fact that we're using character arrays instead of strings. So this part should all be good. Single character. If you remember, the timer will trigger if there's serial available. We're gonna have this one character that'll read in the next serial bit available. Okay, if the single character that we're receiving in is this is just a new line symbol, which means when we print this, we'll have all these characters, and then the last one will be this, because we'll type this in and we'll press enter, and pressing enter can be stored with this. So if we read in that enter has been pressed, we know that we've received a full message. Wait a second. Oh, okay. Okay, so if this is in, that means we have the full message. But first, let's deal with if we haven't received the new line. Speed, message, being received. So remember at the very top we declared this integer, the speed message being received index. It's not index 0, it's just index. And we set it equal to 0 because right now our character array of being received is empty and we want to point to the very first one. But now we're going to set the very first spot equal to the character we just received, and now we want to increment that index by 1. So now it's going to point to the next one. It's going to be 1, and the next time around, this single character will be printed to the next spot in the character array.
So you got an opening bracket that doesn't close to line 180 here?
Oh, yes.
And also you misspelled received before the first opening bracket.
There's not an in received.
Silly job.
It is done. So there's no message, no warning. Fun fact, if you churn bin, you own sudo, which means you can't run sudo, which means you break your install, so you can no longer log in. There's no warning. Welcome to Linux. It's such a Linux thing. I forget if I'm not supposed to do that, but I just did it. Maybe I'll have the accidental humble trial by needing to completely reinstall my properties. Well, I don't care. It happens. I have a desktop that's a one-to-one clone of this, so I don't care. This laptop is just a the desktop is supposed to be because I have a Windows installer. I never intended to run Linux full time. I just was like, oh, I should probably go over everyone else. So I just found this crappy broken SSD before I've been running off it. It's like a 128. It's like perpetually like 2 gigs or but I've been dailying it now. Like, I should do it with all the SSDs. I don't want to run M.2 stuff. I need to store Windows.
Alright. So all this stuff up here, these two steps are receiving the new character, putting it in our storage array, incrementing our index. This is for error checking. If the receive index is greater than 15, which means it's 16, that would mean that we're going to try to put a character into our array, but in a spot that's outside of the size of our array. So that's bad. We don't want to do that. So this is just for error checking. If this happens, we're just going to set the speed message being received to all nulls and start over, and then set our index back to 0. And hopefully that will rectify the problem.
So on the for loop evaluation,
Here?
your double semicolon.
Yes. It's getting late. I'm getting sloppy.
So
They sense the high commission. Oh, that's actually so true. We remember the last time we had that too. Yeah.
Alright, so now, very last thing we have to do, we have to go back. If we have received the new line character, then we need to take in that message. So once again, favorite thing to do, it's another for loop.
President and vice president, I think.
Andrew? Yeah. That's awesome. though. I actually just don't know. Let's see, we lost a pound. It's literally lost plus pound.
I know. So lost.
I'm showing you again.
Why?
You know, stop it. Putting more fan.
Okay.
Doesn't turn on, it makes me angry. And who are you in group? Is it Andy? Is it Andy? Group Andy? That's what I did last time.
You guys both done with all this?
No, I just need a little bit more time, if you will.
Yeah, no, you're good. Yeah, no, you can. I'm gonna stay right here.
Is it working?
You don't have to take a picture.
Makes it easier because you don't let them.
Oh, okay.
That's because you forgot your glasses.
You can pseudo
Otherwise, you're just bad.
executing Dolphin as pseudo is not possible due to unfixable security vulnerabilities.
What?
On GNOME, you can set the GNOME file explorer as pseudo and actually lets you add things in pseudo. It's so useful.
I know, that's the latest component of Dolphin, so you can use it.
Why can't you? Oh,
I think I'm fixing this on this.
wait, I own some. No, I own it. No, I own the file. I actually do own the file. Is it working? Still not working. I literally own the file.
Pseudo.
You're gonna have to do this too if you're gonna see if you're doing the upload. Because there's no way they ever merge it. I still can't load. Usually, like, there's a condition SO6 done. But I own it. It's owned by Andy.
So the flag message received, Blend 183, is that?
So this is, remember this is the interrupt. Read serial message is the interrupt function. If we have received a full message, which we know if we've received the new line character, if the user pressed enter, and we got all the way to that character, then we know we received a full message. We want to set this flag equal to 1, so then in our main loop, we're constantly checking, hey, is that flag 1? And if it is, then we know we have a new message that we have to make sure that our motors are spinning at.
Everyone has to run it.
It's like a true.
Hmm?
It's like a true.
Yeah, we're setting equal to 1, which is the same as setting equal to true. Yeah, I guess, yeah, I could say we're set equal to true.
I can't fucking talk.
Was just me complaining about grammar.
Alright, start the second audio clip. I think you probably, if you're watching the video, may have missed some of the troubleshooting that we did. The part that I realized that I messed up in my code, and Evan, you need to fix this. If you go down to the very bottom, this speed message in line 187, speed message being received, and then it's an array, so I'm specifying what index in that array I want, and it's a variable, speed message being received index is equal to single character. What I had done is accidentally put this bracket at the end, not there, right there, and so the index I was going to was this whole expression. And I'm not quite even for sure what that expression would equal, but then I wasn't setting that equal to anything.
That's the only change to make.
Yes. So if you make that change, and then if you're not getting any compile errors, you should be able to compile it, then upload it to your Arduino. You can go to Tools and make sure you have Arduino Uno selected, make sure your port's correct. And then we're going to open up a terminal. If we scroll to the top, this is the format that I need. I'm going to copy this in. And say I hit enter. In your code, this top line won't. Let me delete that.
Nothing happened.
Nothing happened. Did it display anything back? No. Did you make sure you typed in this precise message?
Yeah.
Oh.
There's no spaces in there, right?
No, no spaces.
Intersect would also be on returns.
You should be able to see that it returns 0 and the percent is 0.